with the unit. So scatter plots we did before break. What we are looking at now is I can sketch a function, the best fitting line for a scatter plot, make predictions using that, and write an equation. So today we're going to go back to equations from point slope form, slope intercept, not so much standard form because they don't work as well with these. So our vocabulary says a trend line is a line on a scatter plot that is drawn near the points and shows a correlation. There should be about the same number of points above and below. So when you look at this, this does not have to be the only line. And so the answers for many of you on this part can be different from the person you're sitting next to, or if you're working with someone on something, or even from the answer in the back, is that it does not have to be exactly the same because it is your interpretation of like half the points above and below. So when you draw that, it says you can use a trend line to estimate the value between two known data points. That's called an interpolation. So interpolation is when you go in between. So if I'm asking you to look at some data and I say, what does it look like for 12 down here? Well, at 12, you can go up from 12 and you can kind of find where that is. You could look and go, oh, I think it's about here. But if I asked you to find 80, 80 would be an extrapolation, because 80 is outside of this range where my data points are. So an interpolation just means it's in between known data points. An extrapolation, if I asked you, well, what's going to happen down at negative 30 when x is negative 30? That would be an extrapolation. When x is 100, that's going to be above this 60. That would be an extrapolation. So if we want to predict the x values for 80, extrapolation. If we wanted to predict for negative 40, also extrapolation. 24, interpolate. So all it means is that extrapolation, interpolation just means in between the known data points and outside of that. So reviewing equations on the bottom of that page, we already said that this form at the bottom is point slope form, right? So we need our x-coordinate, our y-coordinate. So when you are looking at yours, I need you to put the word red by this first one, right? So let's put red by the red line. Because in yours, in the notes, you can't tell the colors, right? And let's put black. And let's do blue. And the first one they are asking us to is to write, so when we are looking at writing those, the form at the bottom that we are looking at is point slope form. So point slope form is when you know what your m is, right, our slope, and you know a point. You have your x1, y1, and you have the slope m. So using that information, we want to write an equation for the black line. Now, it looks pretty nice that it looks like we can even tell where our y-intercept is on that one. So could we even go with slope-intercept form? We could. What do we know our slope is if we use like these 2 points? We're going up 2 and over 2. So my slope for that line is 2 over 2, which is 1. Slope is 1. And if we wanted to use this point, I could write my equation as y equals, my slope, we said it was 1, parenthesis, x minus, where is our x-coordinate? Over at 1. And then, so x minus 1, and then we're going to go plus 4. Do we have to have that equation? No, someone else could have chosen this point, right? You would have had y equals x, and it would have been plus 1 minus 2. So when you look at that equation, I like even slope-intercept form for this one, which is y equals 1x plus 3. Does it matter which equation you use? No. There are many. So we're going to look at the first one. Now let's go to the red line. As you look at the red line, what is our slope first in the red line? M is equal to, it's not as nice, right? How high are you rising up? Up 3 and over 2. Both of these have a positive slope, right? The black line and the red line are both going up to the right, positive slope. So if we're remembering positive and negative with the face. If I wanted to pick a point to use, what point do you want to use, Lulu, on the red line?
1, 1.
we're using this point, y is equal to, we're going to have 3/2 x minus 1 plus 1. Anyone use a different point? Could we use a different point on that line? Christian, give me another equation for that same line, or with a different point. Which point do you want to use?
3, 4.
Okay, so you're going to go here, 2, 3, 4. Okay, so y would equal, we have what?
3/2 x minus 3 plus 4.
Does it matter which equation we have for those? No. So there's more equations, because what if someone wanted to pick this point, right? It looks like my y-intercept is about a -1/2, but I want to be careful with that. But it does look like I could have put it in slope-intercept form also. Okay, so now let's look at our blue line. Blue line, the only thing that's different about our blue line than the last two is that the slope in this one is definitely negative. And we are looking at a negative what? This is an ugly one, right? So down 7 over, what did I hear? 5, -7/5. Okay? And again, you are counting. You are going down 7, and then you went over 5. So as you were looking at that. So rise over run, still thinking about our slope. So if we are looking at this one, Hayden, which point do you want to use?
-4, 4.
-4, 4. So we're using the one up at top. So y equals, if we're using that slope, we're going to have a -7/5. And then Benson, I put what?
X plus 4.
X plus 4, yep.
Parentheses plus 4.
And then another plus 4. Because we're looking at minus a -4, which makes it a positive, x plus 4, and then we went up 4. If we wanted to use the other point that was there, Angus, we would have what? Y equals
-7 x minus 2 r1 minus 3.
Yes. And again, you could distribute these out and write them in slope-intercept form, but to me that doesn't make a lot of sense for these last two. They get kind of ugly. So keeping them in point-slope form. Okay? Scatter plot are an effective way of graphing data to display the pattern, trends, relationship, and identify outliers. The scatter plot at the right appears to show that the longer the students studied, the higher their grade on the exam scores. A trend line was drawn through the data to model the pattern. Does it go through any data points? Yeah. Trend lines can go through data points, but your key thing is when you use your straight edge, you want half the data points above and half below. Does it look like half of them are above and below? Yeah, pretty close. Could someone else have drawn it just a little differently and it still be the right line? Definitely. So I just want you to be aware that when you look at this, if I was drawing this line and I went, you know, I think this line could be more like this. Gives me a totally different y-intercept and the slope is a little different, right? Someone else could say, you know, I think the line should have been more, let's see, let me draw this like this line. Half the points above, not quite half below, but so anywhere you draw that line, you just have to make sure the points are on your line and then you find the equation. So it says if we find the equation for a line, we can use it to make a prediction on how other students might perform. How do you write an equation for a trend line? You need to find the slope and you want to have a point. So pick a point on your trend line and the slope. It does not have to be one of your data points. Could it be one of your data points if our line went through it? It definitely could be one of our data points. So if we're looking at the line that they gave us, we might go, oh, this one, although it seems a little above that point, so we might even pick depending on the point. So they came up with this equation. So they picked a point and they found the slope. They calculated the slope. How do we calculate the slope? That is the change in y over change in x, right? Where you subtract your y's over subtracting your x's. That's how they found this number. They changed it to a decimal. They said, you know what, this point right here looks like 51, right? That's our y-intercept. Could you have used a point on the line and written it in a point slope form? Definitely. That's an equation for the line. So it says we are asked to predict if you study 5.5 hours. Could you easily go from here to 5.5 and go up without using the equation and tell me where that point is? Really close. What we want you to do is to use the equation and use 5.5 as your x value. So if our x value is 5.5, if you have your calculators out, please take them out. 4.7 times 5.5 plus 51. If you don't have your calculator, 5, someone have an answer for me? About what?
77.
About 77%. Did it come out like 76.85? Yeah, so about 77%. The question is, interpolation or extrapolation? Is it in between my data points or outside of those data points? This is an interpolation. It's in between the data points that are already given. So when we are looking at these, those are the kind of things you want to be thinking about. So this might be the question. Does studying for the final exam really help your score? Does one event really affect the other one? So do you think there's causation here? We would kind of think so. I mean, it depends how you study, right? I mean, if you study with YouTube on and everything else going on and any other things distracting you and you're not really focused, it might not be that great of a study session. All right, so writing trend lines. So here is a table for data on that next page down with a trend line showing the weights and ages of baby pandas. So we're asked to write an equation for the trend line and make the prediction. So first thing we want to do as we look at this is we want to try and pick 2 points that are on our line. So if we were looking at points that are on our line that were also data points, to me this looks like a good one. So at 8, right? 8, 37.8. And what would be another one that looks like a good data point? How about at 4? That looks like a pretty good one, right? So if I use these 2 points, 4:17.1 and 8:37.9, first thing we have to do is find our slope. How do you find the slope? These are my ordered pairs, 4:17.1, 8:37.9. So if I'm finding the slope, it's the change in y divided by the change in x. So going way back to the beginning of the year. Change in y, 37.9 minus 17.1 divided by 8 minus 4. I'm definitely going to get my answer as a decimal. So 37.9 minus 17.1 gives us 20.8 over 4. I'm going to divide that, what decimal? 5.2. What does that 5.2 mean in case of this problem? So what's happening? For each month, what's happening? That baby panda is gaining 5.2 pounds each month, right? So if you're asked what does that slope mean, how do you interpret it, okay? So they're gaining 5.2 pounds each month. We want to write an equation. To me, it makes sense to either use the 4 or the 8. Which point do you want to use, Emma? We're going to go to point slope form. Y equals our slope, 5.2, times x minus 4 plus 17.1. And have an equation form. Do I have to write it in slope-intercept form? No, I just have to have an equation for the line. It asks me to approximate the age at 7. Now, some of you will distribute this out, but you wouldn't have to get it in that form. All you have to do is think if x is equal to 7, in that equation, we're going to go back to our 5.2, and instead of x, we're going to put 7 minus 4 plus 17.1. That means you're taking 5.2 times 3 plus 17.1. What does it look like for 7? About how much?
30.
How many pounds? What do you guys get? 7 months, our panda now weighs 32.7 pounds. Interpolation or extrapolation? Interpolation, it's between 12 months to 1 month wait, right? If I said, well, what about at 24 months? Do you think that panda keeps growing and growing at this steady rate? Isn't there a point, just like you, that after a while as a child, you were growing and then you kind of plateaued for a while and then you grew again? And you're just continually growing. All right, so as we are looking at this, top of the next page. Almost done with notes for today so you can get started. Which I do have straight edges for you as you're drawing yours. So it says, use the data to predict the month, to predict the length of the baby panda at 7 and 10 months. Now, since if we are looking at our data, is this the same data as before? No, not the same data, right? So what I'm going to hand you is I'm going to hand you a blank. You want to make sure that like half the data points are above and below that. So if I am looking at your line, and I look at this one, I might have a line that like that. Right? Someone else could have had that line being maybe a little more like this one, right? So you can decide and draw your line. So just make sure you draw your line half your data points above and below. If we're looking at points that go through, depending as you look at yours, welcome back. If we are looking at this, at 2, if we go with this blue line, this looks like we could use that data point. Do we have another data point on that blue one? Oh, right here, right? Use 2 points on your line. To me, these 2 points are pretty close to my line. I could have used this one also. I could have used this point like right here and that point. So pick your 2 points. I am using the point 2, 11.75, and 4, 16.7. Whatever your 2 points are, write those down. So on the test, when we take this test on Friday of this week, you're going to tell me your 2 points for your line. Then you're going to tell me the slope. Slope is equal to, you're going to take your y points and subtract them. 16.7 minus 11.75. Now, if your line didn't go through those same 2 points that mine did, you might want to use yours and find that. So if I am subtracting, and I'm looking at this one, and I have 16.7 minus 11.75, what do we get for that? 4.0, .4.9. Did you subtract the 7.5 or just, yeah? Use 2.47 or if I use 2.5. So my equation, y equals, I'm going to just use the first point that I had on my graph, which was, could I almost tell where the y-intercept is? It's like almost at 5. Could I just use slope-intercept instead of this point? Could I use y is equal to my slope of 2.5, or if you use 2.47, x plus 5, right? I mean, I can, from my blue equation, I don't know if you can tell on yours, but mine went through almost exactly at 5, okay? Could I have used this and put x minus 2 plus 11.75? That would be okay also, right? So just writing that equation. So now we want to compute the 7-month-old. This is when x equals 7. This is when x equals 10. In this case, the 10 is going to be an extrapolation. The 7 is going to be an interpolation. If I go to this equation, because it's easier, and I plug it in, y equals 2.5 times 7 plus 5. Y equals 2.5 times 10 plus 5. To me, those are easier equations to use than this one. It just depends on which answer we're looking at. So in this case, the first one came out to be how much? 2.5 times 7 plus 5? About how many pounds? You guys calculated it, right? Put that in your calculator. What'd you get? 22.1. 22.5 pounds. Could someone have done it in this equation, got a different answer, said apart, oh, I think it's about 23 pounds? Yes, I think both answers, looking at yours. In this next one, we should have had what? At 10 months, how much is it weighing? About 30 pounds. Does that make sense if we look at this? Yeah, kind of depending on, as we look at this one, depending on our line. So approximately 2.5 times 10 gives us 25 plus 5, about 30 pounds. So the question is, what is the slope in our equation? So the slope in our equation was 2.5. And it says, what does it mean? It means that the panda is gaining what? 2.5 pounds per month. If I asked you for the y-intercept, what is the y-intercept for this panda? Y-intercept was 5. Which means what? When the panda was born, it weighed what? Panda was born, so the y-intercept in this situation is telling us when that panda was born, 0 months of age, it weighed 5 pounds. Okay?